Hello and welcome to a video on solving quadratics where a is greater than 1. And what I mean by a is just the coefficient on the x squared term. So the first step in solving these types of quadratics is to firstly factorize. Now if you haven't already, I really encourage you to go back and watch my video on factorizing quadratics where a is greater than 1 before we carry on with solving this equation. So to factorize this quadratic expression, I need to look at these two numbers here and find out what two numbers multiply to get the product of these two numbers here. So 5 times 6 is 30, so I need to find two numbers that multiply together to get 30 and whose sum is this number here, so 13, positive 13. So add together to get 13. So what two numbers are they? Well, if I list all the factors of 30, now which combination of these numbers gives me a sum of 13? Well, it's going to be 3 and 10. So 3 multiplied by 10 gives me 30. 3 plus 10 gives me 13. So what I'm going to do is I'm going to rewrite this quadratic expression, but instead of writing 13x, I'm going to split that up into 3x and 10x. And the whole reason for doing all of this is so that now I can split this expression up into two parts. Now if I focus on this part of my expression, what can I factor out of 5x squared plus 10x? Well, I can factor out a 5x. Both terms have a 5x in, and in my brackets I'm going to be left with x plus 2. 5x times x is 5x squared and 5x times 2 is 10x. And now in this maroon part, what can I factor out? Well, I can just factor out a 3, and in my brackets I'm just going to be left with x plus 2. 3x, 3 times x is 3x, 3 times 2 is 6, and of course all of that equals 0. And now you can see that I've got an x plus 2 here, I've got an x plus 2 here, so I can factor out an x plus 2. So I can factor out an x plus 2, and what I'm left with is 5x plus 3, and of course that all equals 0. So I've done my first step. I've factorized my original quadratic expression, so I've gone from this to this, and now my second step is just to solve this equation. And to do this, we're going to use the zero product rule. Now the zero product rule, quite a simple concept, just states that anything multiplied by 0 is 0. So if you think about what two numbers could I possibly put in here to get me an answer of 0, well, one of them has to be 0. So if I've got 0 multiplied by anything, that will give me 0. So for example, 0 times 3 is 0. Or something times 0 equals 0. So here I could say 11. 11 times 0 is also 0. As long as one of these numbers is 0, then my answer is always going to be 0. So if I apply that to this question here, we've got two things being multiplied together, just like we have here, and the answer is 0. So in order to get 0 as our answer, one of these has to be 0. So we can say that either this equals 0, so x plus 2 equals 0, or this could also equal 0. So as long as either one of those things is 0, then our answer is going to be 0. So, or x plus 3 equals 0. So now I can just write these out as two separate equations. X plus 2 equals 0, or 5x plus 3 equals 0. And now we just need to solve these two equations. So here we're just going to subtract 2 from both sides, and we're left with x equals negative 2. That will be one solution. Or with this equation, if we subtract 3 from both sides, we're now left with 5x equals negative 3, and then we can just divide both sides by 5, and we're left with x equals negative 3/5. So that is our other solution. So I'm going to do a couple more, but I'd encourage you to pause the video and see if you can have a go at solving these two equations yourself. Okay, so the first step is to factorize. We need to factorize this quadratic expression, so we need to find two numbers that multiply together to get negative 9. Okay, 3 times negative 3 is negative 9, and whose add together to get positive 8. Which two numbers are they? So it looks like it's going to be 9 and negative 1. 9 and negative 1, let's just check. 9 multiplied by negative 1 is negative 9, and 9 subtract 1 is positive 8. So I'm going to rewrite this whole equation, but instead of writing plus 8x, I'm going to split that up into plus 9x minus 1x. And now what I can do is I can just break this up into two parts. If I focus on these first set of brackets, what can I factor out? Well, I can factor out a 3x. And then in my brackets, I'm just going to be left with x plus 3. 3x multiplied by x is 3x squared. 3x multiplied by 3 is 9x. And now if I focus on the blue, what can I factor out? Well, I can factor out a negative 1. And then in my brackets, I'm going to be left with x plus 3. Negative 1 multiplied by x is negative x. Negative 1 multiplied by 3 is negative 3. And of course, all of that equals 0. Now we can see that we've got an x plus 3 here. We've got an x plus 3 here. So we can actually factor out an x plus 3. We can factor out an x plus 3. And in our second bracket, we've got 3x minus 1. And of course, that all equals 0. So now we've factorized our original quadratic expression and we've set that equal to 0. So now we can apply the zero product rule. So either one of these expressions is going to equal 0. So either x plus 3 equals 0, or I can say that 3x minus 1 equals 0. As long as one of these is 0, my answer is always going to be 0. So if I just solve these equations, I'm just going to subtract 3 from both sides, and I'm left with x equals negative 3. That will be one solution. And my other solution, so if I add 1 to both sides, I'm now left with 3x equals 1. And now if I divide both sides by 3, I am now left with x equals 1/3. And that is my other solution. Let's have a look at this one here. And again, I need to factorize first. So I need to find two numbers that multiply together to get 36 and that add together to get 13. So what two numbers are they? Well, we could have 12 and 3. That will give us 36, but that won't give us 13. We could have 9 and 4, and that looks like that would work. So 9 and 4. 9 multiplied by 4 is 36. 9 plus 4 is 13. So again, I'm going to rewrite this whole equation, but instead of writing 13x, I'm going to write plus 9x plus 4x. And just like before, I can split this up into two parts now. So the first part, I can factor out 3x. And in my brackets, I'm going to be left with 2x plus 3. And the second part, I can factor out a 2. And in my brackets, I'm going to be left with 2x plus 3. And of course, all of that is equal to 0. So notice now how we've got a 2x plus 3 here. We've got a 2x plus 3 here. So we can factor out a 2x plus 3. And we are left with, in our other brackets, 3x plus 2. And now we can set that equal to 0. And now we can apply our zero product rule, where either 2x plus 3 equals 0, or we can say that 3x plus 2 equals 0. And if we just solve these equations, take away 3 from both sides, we're left with 2x equals negative 3. And then if we divide both sides by 2, we are left with x equals negative 3 over 2. That would be one solution. If we look at our second equation, if we subtract 2 from both sides, we're now left with 3x equals negative 2. And if we divide both sides by 3, we are left with x equals negative 2/3. And that is our other solution. Now, there are quite a lot of steps involved in solving these types of quadratic equations, and you might be wondering, well, why can't I just apply the quadratic formula if you do already know what that is? And you can apply the quadratic formula, but this skill of factorising is really important because it comes in handy in other parts of maths as well.